Hello everyone, I hope you all are doing well and thank you so much for attending in this tag where I'm going to present DPMix, which includes new methodologies for route optimization in mixed networks. To ensure we all are on the same page, I'm going to start my talk with a brief introduction to anonymous communication systems and necessity of having them on internet. Later on, I will discuss with you the issues of mixed networks as a type of anonymous communication systems, and subsequently I will introduce DPMix to resolve those issues. In the end, I will conclude this talk by bringing up the key results of DPMix. Right, so as you might know, when two endpoints on internet wants to communicate, the content of their communication is typically protected using cryptographic operations like end-to-end encryption. However, the fact that these two endpoints are communicating is not protected or hidden from the perspective of a network adversary observing this scenario. And this fact will create serious privacy issues. To address these privacy or anonymity issues, one typical choice is to consider using Tor network. Tor is actually an overlay network on internet which consists of many relays that are known as Tor relays and categorized as guard, middle, and exit relay. In Tor, a client who wishes to have an anonymous communication path to a destination will require to first initialize some key exchange processes with the exit, middle, and guard relay. Eventually, when client wants to forward her packets to the Tor network, she will encrypt them with the keys that have been exchanged, with exit, middle, and guard relay respectively. Under this setting, each intermediate relay after receiving packets from the preceding relay will peel off one layer of encryption to now, as a result, the succeeding relay on the communication path and forward the packets to that relay. Tor network under this specification will provide anonymity for the client to the destination communication. However, this anonymity will be provided under the strong assumption that the Internet Service Provider who observes the communication from the client side to the guard relay is not the same as one who owns the network between the exit relay and the destination. As you might guess, if the Internet Service Provider observes both ends of Tor network, then we will be in trouble. Actually, such an adversary can gather information about the packets entering and exiting the Tor network, and in long run he will create a dataset based on which he will be able to train deep neural networks to figure out who communicates with whom. And unfortunately, research has been shown that the adversary is able to do so with a very high accuracy. So that's a problem. We need to find a better or stronger mechanism for providing anonymity for the client and the destination. To do so, first we need to have a good understanding of mixed node concepts. Mixed node is actually an entity on internet which receives traffic from different clients or different resources. And then the mixed node will shuffle or delay this traffic for mixing purposes and eventually will flush them out. From the perspective of a network adversary observing this situation, then it would be very challenging to map the input traffic to the output one. Thus, mixed node will help us to mitigate the threat of mixed node adversary. To be more specific, we usually use mixed node in a network, which is known as mixed network or mixnets. Mixnets are typically configured in layers, where each mixed node can be part of only one layer. A client who wants to have an anonymous communication through mixed network, similar to Tor, will select one node from each layer and forward her packets to this path. Now, the Internet Service Provider is allowed to observe and corrupt all parts of the Internet, and still he has no clue who communicates with whom. We can even go to the extreme with that. We can consider a scenario where the Internet Service Provider also corrupts some mixed nodes in the mixed network. Even in such scenario, as long as one mixed node along the communication path from the client to the destination acts honestly, the anonymity of the client to the destination will be preserved. So that's perfect. We had a serious issue on internet regarding the identity of the end users, and using mixed network we can perfectly address that. That said, this high anonymity in mixed network comes at the cost of heightening the end-to-end communication latency on the internet. The communication latency is high because in mixed network, compared to a direct transmission, we have to send the packets through some intermediaries. And these intermediaries might be far from one another. They might be from different continents, thus they will contribute to heighten the end-to-end communication latency. On top of that, each mix node will apply some mixing through shuffling or delaying the received packets or traffic, which will further contribute to increase the communication latency. In addition, compared to a direct transmission, we have to forward our packets or traffic in mixed network through some intermediaries. And it will increase the chance of unreliable communication or the chance of having some intermediary mixed node congested with the traffic, which eventually will lead to message drops or communication interruption. In DPMix, we have provided methodologies to address all these sort of issues together. DPMix actually relies heavily on differential privacy guarantee. So as a result, I would like to briefly mention the differential privacy concept. Differential privacy basically aims at privatizing information that is usually gathered from different individuals in form of a dataset. These datasets will be used later for a statistical analysis by running a function f on that. By having directly access to the output of this function will violate the privacy of the individual participated in this dataset. To address these issues, differential privacy provides mechanism that will add noise to the output of this function to avoid privacy leakage. To be more specific, you can consider dataset x1 and the dataset x2. As you can see, these two datasets have the same participant, except for one, where the dataset x1 has the student's information and the dataset x2 has Peter's. Differential privacy guarantees that in such scenario, if an adversary has access to the output of these two datasets after being applied to the differential privacy mechanism, she will not be able to distinguish which output is associated with which dataset. In more mathematical terms, we can bound this advantage as e to the power of epsilon, where epsilon is our privacy loss, varying from 0 to infinity, and we usually try to keep it as low as possible. Although it might not be very clear at the first glance that how these datasets and privatizing them is associated to mixed network, we actually have the same scenario happening in mixed network. To understand this better, we can consider this example where clients wishes to make a communication path in mixed network. But generally client is interested to select the fastest communication path. But selecting the best link delay actually will violate her privacy or anonymity. In other words, you can consider Mixnet as a dataset of its client and destination pair, which is very sensitive, and that's why at the first place we wanted to use Mixnet to protect it. When client tries to select the high quality path, for example, the fastest path, then it's like that they are running a deterministic function on that dataset, which will reveal a lot about their destination. To avoid this issue, in DPMix, we have provided a mechanism which allows clients to assign scores to the path. These scores might be for latency optimization, reliability optimization, or congestion avoidance. Then all these scores will be given to the exponential mechanism, a fundamental mechanism in differential privacy. And then the differential privacy will come up with some distribution. The clients then can sample their communication paths from those distributions. Eventually, client will enjoy having high-quality communication paths in terms of latency, reliability, or congestion avoidance, but at the same time, its privacy or anonymity will be preserved. In more specific terms, you can consider two different scenarios where in the first scenario Alice is talking to Bob and in the second Alice is talking to Stewie. In such scenario, DPMix will guarantee that an adversary observing these two different communication processes, she will not be able to figure out whether Alice is talking to Bob or Stewie. So that's how we can achieve high anonymity in DPMix. We have used DPMix for latency optimization, reliability optimization, and also congestion avoidance in DPMix paper. However, here I'm going to briefly introduce the latency optimization result. For latency optimization, we have different approach as a client for selecting the node. In the vanilla setting, the nodes can be selected uniformly at random. This setting will lead to the highest communication latency, 240 milliseconds, but it will also minimize the privacy loss. In case client wants to use DPMix, she can use it in two different modes. If client does not have access to the latency information from its destination to the exit node of the Mixnet, she can use DPMix to optimize the latency from her side to the exit node of the Mix network. In this case, the latency can be minimized to 60 milliseconds, like 75% of reduction, which looks great, at the cost of slightly increasing the privacy loss. If client has access to the latency information from its destination from the Mixnet exits, then the client can apply end-to-end optimization of latency using DPMix, which results in 20 milliseconds of communication latency, more than 90% of reduction, which looks perfect, at the cost of having privacy loss at 3, which is not that bad if you think about it. So in a nutshell, today we learned that we have a very serious issue on internet regarding the anonymity of end user communicating to one another. To provide anonymity for those users, one of the typical choices is to use Tor network, but Tor is vulnerable to adversaries who observe both ends of the network. To achieve higher and stronger anonymity, you can always use mixed network, but remember that mixed network will cause communication latency to be very high, or it might increase the chance of unreliable communication or congestion at intermediary nodes. To address all these sort of issues together, you can always use DPMix, which is specifically in terms of latency, can provide you with more than 90% of latency reduction. All right, So that's all I wanted to talk about. Thank you so much for your attention. In case you're interested in this tag and you want to have access to this slide or pre-recorded version of this tag, feel free to visit my webpage where you can also find other related blog posts or papers. And in case you would like to stay in touch with me, feel free to visit my LinkedIn page. Thank you.